Tendremos la ponencia de Sarah Jones del Digital Curation Center del Reino Unido. Sarah nos hablará básicamente de la gestión de los datos de investigación dentro del marco de Horizonte 2020. Ella precisamente se encarga, entre otras tareas, de coordinar la herramienta del Digital Curation Center para la gestión de los datos de investigación. Pero sobre todo esto será la propia Sarah la que nos hable. Hay traducción simultánea de esta ponencia para quienes prefieran escucharla en castellano. Si hay algún problema con la traducción, por favor, hacednoslo saber para que podamos resolverlo inmediatamente. Muchas gracias.
Okay, thank you very much, and thank you very much for inviting me here. So I've been asked to talk about managing research data, and I'll touch a little bit on Horizon 2020 as well. So I wanted to start off by thinking about why you may manage your research data. What are the potential benefits or the drivers for this? And in the DCC, we define data management, managing research data, as the active management of data throughout the life cycle. So there are a number of activities that may be involved, all the way from initially planning for your data management, thinking about what data you're going to create, how you'll manage that initially, where it's going to be stored and who will have access to the data, and then what will happen in the long term. And really the idea is that you're actually making very conscious decisions about how to do that, to make sure that your data are handled appropriately. So there are a number of benefits, reasons why you may manage and share your data. I think the primary ones are really benefits for yourself. If you manage your data, it makes your research a lot easier because you don't have too much stuff, you're not drowning in lots of irrelevant versions or duplicates. You know which is the most up-to-date version of your data, so you know which copies to be working on. And also, in the longer term, if you have your data properly managed, it means you can go back to it yourself and reuse it in the future. And you can remember what it was you were working on 5-10 years ago, and you can still reuse that data. There are also a number of research integrity drivers. You want to be able to avoid any accusations of fraud or bad science. You need to be able to validate any research findings that you publish and allow others to actually scrutinize your research methods and check that those results are accurate. So if you manage your data, you're able to do that because you can provide it for others to check. There are also a number of codes on good research conduct. I know in the UK there's a practice that universities sign up to these, and I imagine there's a similar situation here in Spain. So really managing your data appropriately is part of being a good researcher. And you'll probably be aware of many of the research funder mandates. Lots of funders are now asking for data management and sharing plans. So they want to know how you're handling your data throughout the life cycle of your project, and also what your plans are for the long term, whether that data will be shared and preserved. Now, if you manage your data, there's a lot more benefits that can potentially accrue. You may well be able to share your data, and if you can, then I think there are a lot of additional benefits. Others are able to reuse your data and build on your work, and that gets you more credit. There have been several studies that have shown that when the underlying data is shared alongside publications, there's a higher rate of citation. So by sharing your data, you're getting a lot more impact for your research, a lot more visibility, and potentially new research collaborations. There have also been studies that have shown that sharing data and being open increases the speed of science. So by making your content openly available, you're actually benefiting your research community and advancing the work in your field. Now, I just want to touch on some of those benefits in a little bit more detail. The fact that data management is part of good research practice and that sharing and being open is actually what research is based on has come up quite a lot lately. There was a special issue of Nature on data sharing, and there's a quote there from Ewan Burney saying that it was never acceptable to publish papers without making the underlying data available. You know, science has always been based on rigor, really, people being able to scrutinize the results. So data management is just a natural part of that. It's something that is part of being a researcher. And in the UK, there was a seminal report a couple of years ago, Science as an Open Enterprise. And here they've said that actually a lot of the remarkable growth of scientific understanding is due to the fact that researchers have open practices. They share ideas, they share their results and findings and get other people to feed back on that. And that's actually what's at the heart of scientific practice. So being open is nothing new. It's something that we should already be doing. And the Royal Society report called for intelligent openness. And by that, they mean that you're not just making your content openly available, you're making it open in a way that it's accessible to others. Other people can find that material, that data. It's intelligible. They can understand your work. That it's accessible. They can actually rerun experiments and check that those results are valid, and that it's usable. So it's not a case of just sharing content, it's sharing content in a way that's meaningful to other researchers. This report comes from the New York Times. It's from a group of researchers who are doing work on Alzheimer's, and they're showing that by being open, it's actually led to progress on Alzheimer's and actually getting results and getting solutions quicker. And the quote here from the researcher, he says that it was unbelievable because it's not the way they've usually practiced science. But as a community, they decided that, they'd park their intellectual property noses at the door and commit to all sharing their data immediately. And that's really advanced research in that field. So that's one of the benefits from sharing, that if you all do it together, you actually really advance research. And there are also economic benefits to sharing. This example comes from the NASA Landsat satellite imagery. They used to charge for the images. So up until 2008, they sold the images for $600 per scene, and they were selling on average 19,000 scenes per year. And that generated $11.4 million of revenue. So it was a fair amount of money coming in from the images. But in 2009, they made that content completely open, and the increase in use is dramatic. It's freely available on the internet and has been picked up by Google Earth now, and it's 2.1 million scenes that are being transmitted per year, as opposed to 19,000. So it's a huge increase in use. And in terms of the income that's generated, it's 100 million per year for the US economy, so it's about a tenfold increase, but the kind of wider value that's estimated to generate is around 935 million. So it's stimulated a lot of new industry and applications. And I think this is really why groups like the European Commission are really pushing the open science agenda, because there is an economic return to come from it too. But there are also opportunity costs. There are issues with sharing and managing data. And there's a really interesting blog from Emilio Brunner where he tried to calculate the cost of sharing data for just one publication. And he said that the opportunity cost of his open science was 35 hours, so about 1 week's worth of work, and $690. And he breaks that down. There was a little bit of effort preparing the data for deposit to repositories and the time to add associated metadata and upload those files. But the main effort was actually cleaning up and documenting his code. And he said actually that was quite a kind of challenge to overcome mentally as well, to think about being open in that sense. And that was where most of the effort was. And there were also some kind of charges levied by publishers and archives as well. So in his blog, he makes some conclusions about what's needed to drive forward the open science agenda. And he says we need a better system of incentives so that you actually get a return and a reward for managing and sharing data. Now, there are some studies that show increases in citation, but I think we need more direct benefits. And if I understood one of the bits of the presentation earlier, there was I think it was 12 universities in in Spain that actually tie open access to promotion criteria. And I think moves like that are really important so that you're actually getting a direct return. He also says we need to teach our students how to do this now, because if people learn how to manage data early on in the research process, it actually makes life easier because it becomes part of your practice. And I think that's a message that we can all take back to try and embed some data management skills into PhD programs. And also minimizing the actual and opportunity costs. So try and reduce some of the charges that are levied, but also improve the tools and services that we have available to make it easier to manage data. So it's not taking up so much of researchers' time. So his conclusion is that we should stop talking about what people should do, but actually how they can do it. And I think that's a clear message for libraries and services to actually develop better tools. And what you'll hear about this afternoon is some of the work going on here from Seminario Madroño. And I think it's really important that there's more tools coming out to help you in this process. So what I want to do is just reflect on some of the issues that you should be considering in terms of data management, questions to ask. And these are really the things that will come up when you're writing data management plans, some of the issues you need to address. So I've got 10 questions to go through. First off, what file formats are most appropriate for your research? Now, sometimes you may not have a choice of format. You might be using instruments that only export in a certain format. But where you do have options, I think there's some considerations to make. It's useful to think about what's common in your field. You know, what kind of formats are in widespread use and are most accepted? Because if you use those, then the data will be easier to share and will be picked up by others more readily. And if you're planning to preserve and share your data in the long term, if you're using a data center, do they recommend formats? This table here comes from the UK Data Archive. It's a social science repository. And they recommend certain formats for deposit. And essentially, if you're wanting your data to be reused and sustainable, it's preferential to go for more open, non-proprietary formats. And you'll see that reflected in their recommendations. How are you going to name and organize your files? This example here comes from a climate research facility in the States. You can see that they've essentially got a schema for naming all their files. So there's breakdowns to see which site the data was created at, what kind of instrument was used, what level of processing this is at. Is this raw data or is it derived data? And then they have the date, so that it's easy at a glance to see what this data actually is. And there's some basic principles on file naming, you know, to keep the name short, to have dates in a standardized format, not using spaces. That can cause an issue if you're putting content online. So I think it's useful to actually have a procedure that you work to as a group so that everyone's using the same method. If you're thinking about sharing your data, it's really important to think about whether others can understand your data and what information they would need to be able to understand it. So have you documented your processes? Have you documented your workflow, what you've actually done? Some of that information may well be in your research papers, but if there's additional information that others would need to understand the data, that's the kind of content you need to be capturing as you go along. Obviously, if you've developed code to run analysis, that's something you need to keep and share with the data as well, so that others could rerun the experiments. Is it clear what everything means in your data set? You know, are all the units labeled? If you're using abbreviations, these might not be obvious to other people, and they might not even be obvious to you, like 10 years down the line when you come back. So it's useful to keep a proper note of those, have a kind of data dictionary. And when you're making your data accessible, you need to have basic metadata so others can discover and find your data. So information about who's created the data and when, what format it's in, what the rights are, who has access to it. There are a number of metadata standards that can be used, and it's best to use standards just to promote interoperability so that your data set can easily be combined with others. In the DCC, we've started to collate a catalogue of discipline-specific standards, and this is being taken forward now by the Research Data Alliance, which is an international initiative. So there's lots of standards listed there. Have a look and see what's applicable in your field. Thinking as well about where you're going to store your data, there are lots of different options. You may well have added money into your grant proposal to buy storage. You might be running the storage yourself or storing your data on your own devices. There are potentially issues with resilience and security there, and particularly if you have just one copy of the data, make sure that you don't just have one copy, because there's risks of loss or breakage of devices. You're best to use university provision if possible, departmental drives, university servers that are more robust so that they're automatically backed up. But I know a lot of people also look to using cloud services, often because they're collaborating across different universities, and that's the easiest way to make sure everyone has access. And they do actually work very well in some circumstances. You just need to consider the risks and think about what's most appropriate in your context. So obviously, if you have sensitive data, you don't want to store it in the cloud. But I think when you're using cloud services, you need to just consider whether they care about your data as much as you do. You know, if those services go bust, you may well lose your data. So again, make sure it's not just one copy in the cloud. So weigh up the pros and cons of each option. In terms of backup, this is really the reason why you're better using managed services from your university, like the university file store, rather than running your own systems, so that the backup's done automatically. If you are backing up yourself, the basic principle is having multiple copies on different media, so don't just buy two of the same hard drive for backing up in case there's a problem with that device and they both go at once, and keeping an off-site copy. So thinking about what happens in the long term, you need to think about whether you can share your data. And there are a number of kind of considerations to make here. Who actually owns the data? Does your university assert rights over the data? If you're working with commercial partners, you know, what have you agreed to in consortium agreements? So you need to think about who owns the IP and whether you can actually share that data if you have the rights to do it. If you've been working with human subjects and have signed consent agreements, again, you need to think about what the rights are in those agreements. Have you asked specifically for the right to share the data and allow it to be used in other contexts? Or have you only got the right to use it for your particular project and research question? If you're reusing third-party data, again, you need to think about the license that you signed to use that. If you've only negotiated the rights to use it for your project, you may not be able to share your own data if that includes somebody else's IP, if that includes some of that third-party data that you've been using. So if you're able to share the data, again, it's thinking about whether it's in suitable formats, whether there's enough documentation. And I think this is why it's actually really useful to think about these issues up front in a data management plan, so that if you are planning to share data and preserve it long term, you can make appropriate plans from the start so that you don't get to the stage of deposit and find that your data center wants more than you've got. They want it in a particular format or with particular documentation that you haven't got to hand. In terms of data licensing, can you make your data openly available? Do you have the rights to do that? You can use Creative Commons licenses. So CC0 is essentially committing your content to the public domain. It's waiving all your rights. CC BY is attribution only, so people have to cite that the data's come from you. Although they should be doing that anyhow, even under CC0, just as part of good research practice. If you need to place certain restrictions on who can use the data or for what purpose, that's something that you can do and you can make clear in a license. And this guide from the DCC on how to license data outlines the pros and cons of different approaches, and it talks about how you can actually implement your license. It's useful to think about what data needs to be kept in the long term, because you probably don't need to keep everything. At the DCC, we've got some guidance on selecting data and different considerations to make, and we've just released a basic checklist, so 5 steps to follow. So the kinds of questions to ask yourself are, could this data be reused? Is there potential for other people to find value in that and reuse it? Does it have to be kept? Perhaps as evidence because you've published on that data, or for legal reasons you might be obliged to keep it for a set period of time. Equally, you might actually be under obligation to destroy the data if your consent agreements or commercial partnerships say that it can only be kept for a certain period of time. Think about whether it should just be kept for any other potential value there is in the data, and also consider the costs. What is it going to cost to keep your data and preserve it long term? Because really that's what you need to weigh up. What are the potential benefits for yourself and for others, and what are the costs in doing that? And that's really how you come to the decision about what to keep long term. And the final question here is what actually happens in the long term? Who may be able to help you share and preserve your data? There are a number of data repositories out there, and this Re3 data is essentially a catalogue of those data repositories. But there may be repositories suggested by your funder or your publisher, so look for any guidelines or recommendations. There may also be certain data centres or community databases for your given discipline. And I think it's always better to share your data in a disciplinary archive if possible, because then it's with similar data sets. It's going to be more discoverable. It's going to be where your community's looking for that research. Your university may also offer support and have repositories, so check that out. One I wanted to just flag as essentially a catch-all if you don't have any other service to use is Zenodo. This is an initiative run by OpenAir and CERN. It's a multidisciplinary repository, so it'll essentially take any content, both publications and the long tail of research data. And they provide DOIs, so you have a unique ID for citing your data. And what they do, Zenodo, it ties up with the OpenAir service, so they link together information about your funding, your publications, your data, and your software. So it's to try to bring together all of your research content. And this guide from the UK Data Archive is a really kind of good place to start on how to manage and share data. So I'd recommend that for more information on how to actually handle your data. Now, what I want to do to close is just to think a little bit about open access and the open data pilot from the Horizon 2020. And I'll talk specifically about some of the guidance and support that's available, because you'll hear more about the requirements later on. So why is the Commission interested in open access and open data? This is their main document, their guidelines on open access. And in this, they say that the Commission's vision is that information already paid for, if they funded research from the public purse, shouldn't have to be paid for again. So they don't want to have to pay for access to publications or access to data. And really, they want to make sure that it's openly available to benefit European companies and citizens to the full. So it's really about driving the economy, getting more bang for their buck, really, so the best return on investment, and making sure there's the most reuse of data as possible. So what is open data? We've talked about managing and sharing data, but I want to just differentiate open data specifically. Open data and content is content that can be freely used, modified, and shared by anyone for any purpose. So earlier in this morning's talk, you saw the scale of kind of levels of open access. It's similar with open data, that you can share your data with restrictions, but open data is actually when it's out there and you're allowing people to do anything with the data. And Tim Berners-Lee has this 5-star scale of open data. So the first star there is making your stuff available on the web in whatever format under an open license. So that's essentially the basic definition of open data. But you want your data to be as reusable and useful as possible. So when you go through the stars, you'll see that he talks about making data available in a structured way. So, for instance, you're not just putting up a screen grab of a data table. It's actually available for people to reuse and repurpose. Making it available in non-proprietary formats, using URIs to denote things, and linking your data to provide that additional context. And when you look into the Commission guidelines, you'll see that they're really pushing for those higher stars. They want the data to be available with additional information about the tools and software that you've used, or ideally actually with the tools and software if you're able to share them too. So how do you make your data open? This is guidance from the Open Knowledge Foundation. They suggest 4 steps. So first off, choose your data set. What is it that you want to make open? And bear in mind that you might need to come back to this step because you may find that you can't make that data openly available. The second step is to apply an open license. So you need to think about what IP exists, whether you have the rights to make that data openly available, and then pick an appropriate license. Make the data available, so provide it in a suitable format. Here it's useful to look at using repositories, so your data becomes widely available, and make it discoverable. Post it on the web, register your data in catalogs so that people know it's there and find it and reuse it. One of the other aspects you're going to hear a lot more about later on is data management plans. That's a requirement in the Commission's Open Data Pilot, and we offer a lot of support on data management plans in the DCC. We've looked at different requirements both across the UK and overseas to see what should be covered in a data management plan, and we've provided a basic checklist of the main themes you should be covering. We've also got guidance and tools like DMP Online. There are a number of services that the European Commission has funded, which if you're taking part in the Open Data Pilot are definitely useful to reuse. So Open Air, we actually heard in this morning's presentation, is one of those services. This is about providing infrastructure for open access across Europe, and it focuses primarily on publications. What it does is it aggregates content from different repositories so it has a full list of publications, and then it mines and enriches that content and links things together. So it will try to link up publications from a given project from different contributors. You might have an international project where you've got people working in different countries. They're obviously depositing in different repositories, so OpenAir is a way to try and pull that content together. And they provide some really useful services and APIs. One of the services in particular that's probably of interest to you is one to generate publication lists. You can go and get a publication list for your repository, for your project, and embed that into your website. And then whenever somebody adds content to one of the repositories, that's pulled into OpenAir and fed out to your website. So it immediately updates your publication list without you having to go and do it each time somebody has a new paper. UDAT is another service offered by the European Commission. This again is a data infrastructure project. It offers a number of services, a lot that are actually useful during the research process. So they're all called B2 something. They have a B2 drop service, which is like Dropbox. It allows you to sync and exchange data. So that's potentially useful if you're collaborating across a number of institutions. They have a share service, a staging service for getting large-scale data to computation, a replication service, and they also have B2 Find, which is essentially a catalog. It's like a registry service, so you can try and improve the discoverability of your data. And one of the new things that UDAT has just released is a licensing tool. So if you're planning to make your data available, that's a useful resource to look at to see what's an appropriate license to use. There are also a number of discipline-specific infrastructure projects. I've noted a few of them here. You'll see that they cover lots of different areas. So Daria, for example, in the arts and humanities, one's covering language research and materials science. Often these infrastructure projects are built around a kind of collection of data. So the European Social Survey, for example, it's building tools and resources around particular collections. But again, I think these are useful services to look at to see what support's available in your community. And the final project I just wanted to flag is Foster, which is a training project. It's for open access and open data training across Europe. We're creating a repository, essentially, of training materials. So if you're training on open science, there will be content there that you can reuse. There are also a number of e-learning resources which are being created, and again, they'll be available over the summer. And there's a training program. A number of projects have been funded in different countries, and I had a look at what's coming up to see there are some events coming up in Spain, in Madrid, Valencia, and Gijón in May. So by all means, go along to the Foster training and learn more about open data and open science. So that's all I had to cover. By all means, consult DCC resources and contact us if you have inquiries. Thank you very much for listening. Gracias por su atención. And I'm happy to take any questions. Do you want questions, or shall I just... Do you want questions, or are we ready?
Tendríamos tiempo para hacer algunas preguntas. Si alguien quiere dirigir alguna pregunta, tenemos aproximadamente 5 minutos. Os aconsejaría que aprovecharais que tenemos aquí a Sarah para dirigirle las cuestiones que se os ocurran. Veo que ahí hay una persona, por lo menos.
Hola, buenos días. En nuestro caso, nosotros participamos en un proyecto europeo, pero no estamos vinculados a ninguna universidad. Somos del Colegio de Sociólogos y Politólogos de Madrid. Al ver que debíamos subir las cosas a algún repositorio... Ah, claro, que es para la ponente, entonces. Hello. We don't belong to any university... Ok, claro, perdón. Vale. Nos preguntamos, en caso de, ¿hay algún, como sugerís que los tenemos que enviar los datos a algún repositorio de nuestra institución? ¿Hay algún repositorio que pudiéramos o que ya nos aconseje utilizar en este caso?
Okay, so it's a question about which repositories to use, which ones I'd advise. The point I was making was that if researchers are looking for a repository, and there's a repository in their discipline and an institutional service, I think it's probably better to put it in the discipline-specific repository so that the data are handled with other data associated with that discipline. Because in the UK, we're having a number of institutional data centres being set up, but most of them are saying that that's essentially like a last resort. So if there is another service that researchers can use in their field, they should use that, because that service is going to know a lot more about their type of data, whereas the institutional service is generic. It's going to be covering all types of data, so it's not going to be so specific to that type of research. So what I would suggest, if there's a repository in your particular research field, use that initially. If not, an institutional one, or there is a whole list of repositories out there. The Zenodo one, again, is generic, but it's a catch-all. So if you don't have a discipline repository or an institutional one, you could use something like Zenodo as a kind of catch-all, and that's funded by the European Commission. So if you're in the open data pilot, that's something that they should be recommending and fine with.
¿Más preguntas? Gracias, sería la última pregunta.
Okay, so you have been talking a lot about how to make your data open data, but maybe you didn't talk that much about how to link it or how to do the linking to other datasets. So how do you propose to do that, or do you have anything to tell us about that?
I think just making sure that you're using repositories and services and the appropriate standards for your field so that your data's there with other associated data sets and you can link things together. I don't know much about linked data. That's not my area of expertise. But I think, using standards and appropriate technologies like RDF so that you can link up data sets.
Bien. Quizá podría dar tiempo de otra más, ¿eh? Si hay alguien más que preguntar. Genial, gracias.
Thank you. Is there a problem with using multiple repositories? I mean, it's all right if I deposit things at my university, at the thematic database for whatever area and wherever else, right? Or not?
Yeah, I don't think there's a huge problem because, it's good to make sure your data is going to be preserved, but you might end up with like multiple there's kind of an issue if researchers are having to deposit in multiple places, like if the university is recommending one place and the funder another, that it's more load, that if we can actually have exchange between those repositories, so you only have to deposit in one place and then it's maybe replicated. I mean, I guess long term, if we're handling large volumes of data, you don't want every repository to have to do that, so agreements between them would be better. But from a researcher's perspective, if you want to put it in two places, I don't think that's too much of a problem. It gives you at least two places where it can be found and reused, but make sure that you have a single DOI, so you're actually getting one kind of unique ID for it. Go back to the technical expert.
Tarda. De todas maneras, parece ser que hay un ligero retardo, desde que se enciende hasta que de verdad se pone a funcionar.
¿De acuerdo? Sí, se oye. La pregunta sería una continuación de la anterior. Bueno, ya que he empezado en español, termino. Quería preguntar sobre otro tipo de repositorios no institucionales, y estoy pensando concretamente en academia.edu, y un poco como continuación a la pregunta anterior, si es posible tener o utilizar tanto un repositorio institucional y un repositorio, creo que es privado en este caso, y cómo funciona, cuáles son sus recomendaciones. Muchas gracias.
So academia.edu, I think I would argue it's more of a service to improve the discoverability of your research, so to detail what research you've been doing. Although you can upload your papers, I'm not sure how well they're managing those long term. So it's not a repository in the sense of somewhere that's making commitments to preserve your data. So I guess I'd view it more like a third-party cloud service. So, you can upload content there, but you don't really know how long they're going to be keeping it. It's not like a a well-established data repository that you know they have preservation processes in place. They maybe have things like the data seal of approval. They've got some form of accreditation that says this is a trustworthy repository. They have processes in place to manage the data and secure it long term. Services like academia.eu are really just about improving discoverability. They're not making commitments to actually manage and preserve your content. So you can upload it there and it makes it found and improves that, but you may not have it there in 10 years' time when you come back. If academia.edu decides to close, what happens to your content? So I think that's where, when you're thinking about the long-term preservation, you want to look to things like institutional services or established data centers that make some commitment about what they're going to do long-term.
Bien, pues muchísimas gracias a todos por vuestras preguntas.